Flow of heat. Learning objectives. Modes of heat transfer. Conductors of heat. Thermos flask. Heat is a kind of energy which causes sensation of warmth. It indicates quality of heat energy passed by a body. Heat from a hot body is transferred to a cold body in 3 different modes or ways. Let us study about each of them. Modes of heat transfer. Transfer of heat. I. Conduction. 2. Convection. 3. Radiation. I. Transfer of heat by conduction. The transfer of heat energy between different parts of a body or from one body to another in contact with each other is called conduction. The conduction of heat energy stops when the 2 objects attain the same temperature. For example, mercury of the bulb in contact with the hot object absorbs the heat and its level within the stem of thermometer rises. When the thermometer and the object are at the same temperature, further transfer of heat stops and the mercury level does not rise. Conditions for heat transfer by conduction. 1. The 2 objects should be in contact with each other, for example, the hot object and the thermometer, the flame and the metallic rod or vessel, etc. Warming hands over fire. 2. The temperatures of the 2 objects should be different. Heat flows from a hotter object to a colder one. In kitchen, holding hot pot with cloth. Activity 15.1. Take a flat aluminium rod and fix some nails on it as shown in figure with the candle wax. Now fit the rod to the stand and heat the other end of the rod over the spirit lamp. As the rod gets heated, the nails fixed with candle wax fall down gradually. The nails fall one by one, showing that the heat is transferred from the end over the flame of the other end. The heat is transferred from one end to another. Activity 15.2. Take 2 rods, one made of aluminium and the other made of iron. Follow the same steps as given in the above experiment. Fix nail on both the rods and arrange them as shown in figure. Now heat both the rods at the same time. The nails fixed on aluminium rod drop earlier than the nails fixed on iron rod. The aluminium gets heated faster than iron. We have learnt earlier and know that the molecules in a solid are packed close together. When one end of the solid is heated, the molecules there absorb the heat energy and start vibrating rapidly. These molecules then cause their neighboring molecules to vibrate. This process continues along the rod end. Heat energy is transferred from the hotter part to the colder part. Such a transfer of energy from a hotter end to colder end, different parts of a body, or from one body to another in contact is called conduction. Sci facts. Conduction of heat also takes place when 2 bodies at different temperatures are brought into contact. Conductors of heat. Substances. 1. Good conductors. 2. Bad conductors. 1. Good conductors. All substances do not allow the conduction of heat through them. Those substances which allow the heat to pass through them easily are called good conductors of heat. If we hold an iron rod at one end and heat the other end, the heat conducted through the iron rod can burn our fingers at the other end. Thus, metals are good conductor of heat. Uses of good conductors in our daily life. I. Making utensils from metals and alloys like brass, aluminium, iron, stainless steel, etc. because they absorb heat quickly and conduct heat to the food inside rapidly and efficiently. 2. Mercury metal is used in making thermometers because it is a good conductor of heat. Metal utensils. 2. Bad conductors. All those substances which do not allow heat to pass through them easily are called bad conductors of heat. Almost none or very minute amount of heat may be conducted through them. They are also called insulators of heat. Example of these are wood, leather, asbestos, paper, all gases and liquids, except mercury. If we burn a piece of paper or cardboard at one end, we can hold it at the other end as heat is not being conducted through it. Uses of bad conductors in our daily life. We use brick, mud, wood, straw, etc. to build houses. These substances, being bad conductors of heat, keep the heat confined at its place. 2. Roofs and sheds are made up of asbestos to keep the houses cool. Asbestos-made roof. 3. Bad conductors are used to cover vehicles carrying inflammable substances like petrol. Otherwise, the petrol can get hot and catch fire. 4. The handles of utensils used for cooking food, such as kettles, ladles, etc., are made of wood, ebonite or wrapped with bamboo or cane strips. These insulate heat and one can hold the utensil while cooking food. Handles of utensils made of bad conductor. Pressure cooker handle made of bad conductor. Fur of sheep. 5. Fur of animals and coats made of fur, leather, wool, etc. all insulate heat. They keep the animals and human beings warm during winter. 2. Transfer of heat by convection. The liquids and gases are heated by the convection method. The process, in which the hotter fluid moves and transfers heat to the colder surroundings, is called convection. Only liquids and gases convect heat. Solids cannot convect as solids do not flow as liquids and gases do. Examples. A. Dissolving sugar in hot milk. When sugar is added to hot milk and stirred, the hot milk moves and transfers heat to the colder surroundings, including sugar, due to convection. Whereas sugar, being cold, does not move as the hot milk does. Hence, it takes time to dissolve. It shows that convection helps in dissolving sugar. B. Air is a bad conductor of heat. As a gas, air can flow, spread fast and transfer heat by convection. That is why we first feel hot when the fan is switched on. The hot air circulates and transfers the heat to us by convection. Also, when hot air rises, it transfers its heat to the cool surroundings. C. Occurrence of storms. The hot air moves up when it is heated or absorbed heat from the surroundings. Then a vacuum is created. The cooler air rushes from the surroundings to occupy the space, resulting in occurrence of storms due to convection. Applications of convection. 1. Land and sea breezes. 2. Ventilation of houses. 3. Central heating of buildings. 4. Use of thermos flask for keeping liquids hot, tea, or cold, ice water. Land and sea breezes. A land breeze is created when the land is cooler than the water, such as at night, and the surface winds have to be very light. When this happens, the air over the water slowly begins to rise. As the air begins to rise, the air over the surface of the ocean has to be replaced. This is done by drawing the air from the land over the water, thus creating a sea breeze. Land breeze. A sea breeze is created when the surface of the land is heated sufficiently to start air rising. As air rises, it is replaced by air from the sea. You have now created a sea breeze. Sea breezes tend to be much stronger and can produce gusty winds, as the sun can heat the land to very warm temperatures, thereby creating a significant temperature contrast to the water. Sea breeze. Thermos flask. A thermos flask is a special type of vessel which keeps hot liquids hot and cold liquids cold. It is a double-walled glass vessel. The inside of the outer wall and outside of the inner wall are silvered. The whole system is enclosed in a metal case with non-conducting supports, cork or rubber pieces on all sides. The mouth is closed with a cork or rubber. The non-conducting stopper supports the glass body and the vacuum prevents the transfer of heat by convection. Thermos flask. Sci facts. The thermos flask was invented by Scottish physicist Sir James Dever in 1892 and is sometimes referred to as a Dever flask or Dever bottle after its inventor. When we pour a hot liquid in the flask, Heat cannot escape from the flask by conduction or convection, because there is no air between the double walls of the flask. As for radiation, the brightly silvered outer and inner surface of the inner wall is a bad radiator of heat. So, inner wall does not radiate heat from the hot liquid. The glass is itself a bad conductor of heat, so the hot liquid remains hot for a while in the flask. Take a round bottom flask of 500 milliliters and fill it half with water. Tighten it to the clamp of the stand. Now add a few crystals of camphor. Adjust the wire gauze over the tripod stand. Heat the water over the spirit lamp. The water gets heated. The camphor crystals get dissolved and the colored water is seen moving in vertical and circular motions. The liquids are heated by convection. Here, the liquid in the bottom of the flask gets heated first. This warm liquid, being lighter than the surrounding cold liquid, rises up. The colder liquid moves down and gets heated and in turn rises again. These are convection currents. Convection of heat in water. If the hot water from the lower part is somehow stopped from rising up, little heat would be transferred to water in the upper part. Activity 15.3. Fix a small piece of ice wrapped with a wire gauze in the bottom of the boiling test tube. Take water in the test tube and boil it as shown. Fix the test tube to the holder and heat it in an inclined position. Only the upper portion near the flame is heated. The heat is not transferred to the lower part, because the ice does not melt. Water and glass are bad conductors of heat. Even if you touch the base of the test tube with your fingers, you will find that it is cold as it was earlier. The warm water, being lighter, remains at the top of the test tube. It does not move down, thus no convection takes place and the ice does not melt. What would have happened if we had the piece of ice floating on the water surface and we heated the water from bottom of the test tube? Would the ice have melted? Yes, it would melt. Give the reason for it. 3. Transfer of heat by radiation. The third mode of heat transfer is called radiation. 1. The heat transfer by radiation does not need any medium for transfer of heat between the two bodies. It even occurs in vacuum. The heat rays are emitted from the source of heat. It can be compared to a lit bulb or a candle light rays. The hot object radiates heat rays to the colder surroundings. 2. All hot objects transfer heat by radiation. 3. We receive heat from the sun by radiation. The heat rays radiated by the sun in all directions travel to all the planets. This is why the sunlight is hot, because we directly receive it from the sun, whereas the moonlight is cool because it is the reflected sunlight. 4. The amount of heat absorbed by a body depends on the distance between the source of the radiation and the object. Nearer to the source, larger is the heat received by the object through radiation. So, the planets, which are far away from the sun, receive less heat radiation from it than the Earth does. Thus, they are colder comparatively. The temperature on the planets depend upon A. The distance from the sun. Planet. Distance from sun in million kilometers. Average temperature in degrees Celsius. Night. Day. Mercury. 58. Minus 260. Plus 410. Venus. 108. Minus 40. Plus 450. Earth. 146. Plus 2. Plus 40. Mars. 227. Minus 100. Plus 40. Jupiter. 775. Minus 150. Plus 40. Saturn. 1416. Minus 170. Plus 50. Uranus. 2866. -170, -150. Neptune, 4493, -170, -150. Pluto, 5904, -170, -150. B. The atmosphere around the planets. It causes temperature variations in the daytime and nighttime in each planet. The atmosphere acts as a heat insulator. Mercury and Venus have atmospheres which give a heat cloak to these planets. They become very hot during the day and very cold after the sunset. Earth and Mars have the optimum distance from the Sun and the atmosphere envelope. Thus, there is no large variation in the temperature of the daytime and the night. Uranus, Neptune and Pluto have no atmosphere around. 5. The amount of heat that an object can absorb by radiation depends on its color. During summer, we prefer to wear light-colored clothes because they do not absorb heat and are pleasant and soothing to eyes. During winters, we prefer to wear dark-colored clothes because they absorb heat and keep us warm. Black surface absorbs more of the radiated heat from the sun. Dark-colored bodies absorb radiation and also emit radiation better than light-colored bodies. Activity 15.4. Take 2 tin cans of equal size. Paint one of them black. Pour equal volumes of water in both the cans. Note the temperature of water in each can. Keep the cans in direct sunlight for an hour. Note the temperatures of water in both cans. The water in black painted can get warmer sooner than the water in the other can. Thermometer. Applications of radiation. 1. White and light-colored clothes are more suitable in summer. Dark-colored clothes are more appropriate in winter because they keep us warm. 2. Polished surface of room heaters radiates better and emits more heat. 3. The base of cooking utensils is painted black at the bottom to absorb more heat. 4. Radiators in cars and other automobiles are painted black for maximum radiation. 5. Solar cooker is painted black inside so as to absorb more radiated heat. 6. Thermos flask with silver glass surfaces prevents heat loss due to radiation. 7. Heat is absorbed by solar cells radiated from the sun. Room heater. Solar cooker. Thermos flask. Keywords. Conductors. The substances which conduct heat. Conduction. The mode of heat transfer in solids. Convection. The mode of heat transfer in liquids and gases. Radiation. The mode of heat transfer to substances which are far apart or not in contact with each other. Summary. There are 3 modes of heat transfer: conduction, convection and radiation. A solid transfers heat to another solid in contact with it by the process of conduction. The transfer of heat stops when the temperatures of the two bodies are the same. Metals are good conductors of heat as compared to wood, paper and glass. Transfer of heat in liquids and gases takes place by convection. Transfer of heat from a hot object to a cold one without any medium in between is called radiation. For example, the sun. Dark-colored objects are better absorbers of heat by radiation than bright objects. They also emit radiation better.